Brian, why don't you come just so everybody can see you? This is my son Brian. He's the electrical guru over there. Of course, you see how bigger he is. Me, closer to the camera. That's what it is. So, but I can't do any of this stuff if it wasn't for him. Last month it was my granddaughter. So let's get into this. Let's see what kind of trouble we're gonna get into. Meter usage part 2. I'm gonna use my clicker. Hey, clicker works. I hope everybody sees the slide going by. This is me. Don't even worry about me. It's what you guys get out of it. So what we're basically going to do is, just because there might be people that weren't on to see part 1 meter usage, but just going to do a quick review of meter usage on that. It's not going to be the whole set of slides we did last month. But we're going to play around doing some proper meter hookups of various circuits. And you know what? We're all going to learn about it. Maybe we'll learn a few things that you didn't expect. And, for those of you that are veterans, maybe it's just a refresher and something might click. Oh, yeah, I do it this way. And, hey, there's another way of doing it. And ultimately, that's another thing. Everybody has their favorite way of doing things. But the whole idea is hopefully the end result is the same. And you reach to your conclusion with whatever you're trying to diagnose. And again, I already said it, with that. Last month, and we started out with a bunch of, first slide was showing a bunch of different meters, and guys, the whole idea was that, and especially myself, the reason I have tons of meters is I do 2-day electrical courses, and it really emphasizes digital ohm meters. I got circuits everybody has to play, but the problem is too, not everybody comes in or has a meter, because these are guys from their first exposure, and there's veteran guys. So some of those meters you see, of course, you guys know the flukes are, you can't get any better than that, but you'll see a whole array of other meters and stuff. They basically work the same. Actually, I'm going to take a few of the others just to show that with fluke do a little bit better, and we'll walk through all that stuff. But regardless, whatever you can afford, you're not going to get away without using a meter in today's world, And of course, I got an array of inductive clamp meters. I love each one of them. They work great, but if just think about the word amp, clamps, amp meters. And I'm going to try to, let me go back. Button knowledge issue. I want to see if I get my Zoom going here. I'm having problems with my Zoom. Okay, if you count over, why isn't my Zoom working? Maybe you can see the pointer here. Okay, I like the ones with, and I could have brought them out with the cables here, because what happens is if you're reaching in a tight spot, this gets hooked up to a meter and you're actually really looking at a meter. These without the cable, they're good, don't get me wrong, but however, you can picture yourself, you're kind of straining your neck, and you got to be double jointed if you're wrapping it around a wire someplace deep in an engine. So even all of these have their advantages and disadvantages, okay? But they work great too. Now, if you're doing amp readings, I'm going to be very honest with you, they're not going to be as accurate as you actually breaking a circuit. And here's an example of, actually being hooked up to the meter. They all work very well. We use them. We use them a lot, even with diesels, especially with smaller diesels with glow plugs and stuff. They work great. They really do, So at a minimum, you can wrap it around a wire, and you can even think about it as a no-go. There's electricity actually going through it. So, good functions, when you use them. Basis of any electrical diagnosis is accurate information. I mean, that is more true today than it ever was before. I mean, you're working with some very, very, very small measurements, and basically with what we're trying to diagnose today, there's such an interrelationship between all the components, and of course, throw in the mix, where's all that information going? It's going to that switch that we know of as a computer controller, okay? And the problem is, again, I mentioned last month, we can't see those electrons flowing through that electrical circuit through your conductors and so on. I mean, do we see the end result? Absolutely. The bulb comes on, the motor turns, and everything else, But basically, that's all we know. We might visually see, hey, the bulb is bright or it's dim or whatever, and all of a sudden we will suspect an issue. We're talking about stay with the bulb, but now we're going to determine how much and what direction the current is flowing or the resistance to that current flow. Is there excessive resistance? What's dimming the bulb? So you're going to need meters, okay? So the bottom line is, if you want to look inside the circuit, interpret its functions, you're going to have to use an electrical service tool, such as a meter, Most common tool that you use today, actually it's a digital multimeter. A lot of people refer to it as a digital volt ohm meter, okay? Whatever you're comfortable with. And really the primary measurements or properties of electricity you really want to go after most of the time is the voltage, the pressure, amperage current measured by the ammeter, and resistance, of course, to that amperage flow. Okay? The load is resistance, by the way, but it's a designed, engineered resistance. What we always look for is that unwanted resistance, so we'll get a little bit into that. So the digital multimeter is a nice tool because it combines these functions in a single convenient, simple to use unit. And they're very rugged, guys, okay? And of course, don't forget there are other features to it. You have to get comfortable with your own meter, It's called RTFI, read the freaking instructions. Now, another advantage is meter protection. Meter protection circuits, internal, of course, prevent damage to the digital volt ohm meter. They're not like the old analog meters. If you hook them up wrong, polarity sensitive, you bend the needle, and from that point on, you didn't have the good measurements. Those old analog meters, you'd have to adjust them, adjust the needle, and a real pain in the butt, but they worked for years, The specification of input protection indicates the amount of voltage overload which may be applied to any function or range without damage. So all the meter manufacturers, doesn't matter if you paid $20 for a meter or, $500, $600, they're pretty good, And usually the circuitry is protected by fast-flowing fuse in series with the input lead. Another nice thing about these meters that you can do your manual ranging, but you know what? Start out with the auto ranging, automatically adjust meters measuring circuits to correct voltage, current, resistance. It depends on what you want to do. Break in there with your manual ranging too, because these meters, they go to four places typically, so if you ever go into the manual, you see this decimal point move, blah, 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 blah. Typically, the digital volt ohm meter starts on the lowest range, automatically moves to the next higher range when in your auto range, Manual range, of course, overrides the auto range to allow for measurements within a specific range. So you got a lot of stuff you can play around with these meters. And I did do a big, huge thing about it last month. And the reason I really emphasize on this is, and I find this in my electrical classes, guys come in with meters and I really require them to kind of take current measurements. That means breaking into the circuit. And chances are pretty good this is the first time everybody, a lot of the guys have to break into a circuit to get the amp reading. And all of a sudden in the circuit, for example, the bulb doesn't come on because this meter becomes a electron counter, becomes part of the circuit. And everybody's, there's something wrong with the bulb. There's something wrong with this. You got to break in the circuit. And I'll be honest, very honestly, to tell you the truth, put your circuit back together, the bulb lights, put this in there, chances are pretty good you got a blown fuse. And those fuses on some of these get pretty pricey on the flukes. As a matter of fact, I got to order some. I used to keep quite a few around, so if guys lost them, if they happen to have a fluke, I would just give it to them, a little bit of courtesy. So, but I ran out of them, But you can test these, with fluke. Here's an example. Set the rotor switch to ohms, plug the test lead into, your volt ohms input terminal, touch the probe to the A input. Don't forget, those terminals, they do have a split contact, so make sure you touch the probe to the upper half. And there's your display. If it's OL, you got a problem. Okay? And you can do the same thing on your 1 amp portion of it, the smaller one. Basically do the same thing. And there's your specs for that. Display should indicate between, 0.900, 5,000, and so on. Again, if it's OL, you got to replace it. Okay? Is it important to test a fuse? Again, yes, it is, because you don't want to get in a situation that someday you're going to decide to take some amp readings, and all of a sudden you get an OL in there, and now you're over there saying to yourself, oh, I think I found a problem. There's something wrong with the circuit, and it'll lead you down a rabbit hole. Guess what? When all this time, it was your meter, not the circuit. So again, important reminder, and most meters work the same way. Take a lead and go from volt ohm meter, connect to an amps jack. If you read LL, you got a blown fuse. Fluke actually beeps if the fuse is good. If a lead is in the amp jack and you select volts, it's a warning. Okay, so that's a nice thing. Again, do check them periodically before doing amp readings. Don't misdiagnose. Digital meters, advantages, they are easy to read, best for finding precise value of voltage, current, or resistance. Readout is accurate to 4 places in most cases, and I put example here, 12.25 volts, or you can see the decimal point move, 0.654 amps. These are just examples, okay? The other thing is the digital volt ohm meter has a high internal resistance, up to 10 million ohms. With a 10 meg ohm resistance, the internal amperage is extremely small. You connect it, when it's connected, it doesn't add any load to the circuit. This makes it ideal for use in very low amperage computer circuits. Test light has a low resistance / impedance. Guess what? This can, for example, cause an airbag to deploy. You stick it in the wrong hole, you're going to ask for problems, okay? So again, ohm meter is 10 meg ohm of resistance, prevent airbag, if you're stuck with the airbag, okay? Airbag deployment or causing other electrical damage due to low resistance. Again, low resistance equal high amperage. I'm going to do something real fast. I told you I prefer playing with stuff. So I have something set up over here, and I got Brian's going to zoom in. We're going to zoom in on this board over here. Okay, so if you zoom in, I have a bunch of, I'll turn my Fluke on. I like my Fluke. I might do a couple of things here. So, you're going to have to hone in and out. So, basically, if you look at the circuit board here, and you can zoom in even more if you want, you zoom right in. Okay. So basically, this circuit board here, I have 3 resistors, okay? I'm not sure in what series they are. One's 100 ohm, one's 1,000, one 10,000 ohm, and I got this bulb here. But what happens is, the reason I picked resistors is that inside the computer, if you can see this, okay, if you can hone in even more, there's a bunch of resistors in here. That's typical of all the computers over here, I don't care what controller, but you can see the little resistors over here. And then if you look in the board over here, the reason you have the resistors in there, you're trying to really make sure that you're getting a dropping down the current. So I have my Fluke on. Okay? So I have it on ohms over here. I'm in the right pocket, because that's one of the things. Always make sure you're in the right pocket. If you're going to do current reading, switch it over. So for the heck of it, we have 995 ohms. We have about 1,000, give or take. I'm not going to split hairs with a 1.026. There's a K in front of it. And here we have a 10,000 ohm. Okay, so because I'm going to hook it up in parallel, the rule of parallel circuit is that and the resistance will always be less than the smallest resistance. So I'm not adding up 10,000, 1,000. When I put them in parallel, and you'll see over here, okay, I'm making a parallel connection, guys. Okay, is always less than the smallest. What was the smallest? What did I say? I believe it was about 100, right? So now if I put my leads in over here, 897 ohms. So actually I was right. In a parallel circuit that brought it down. Now I'm going to do something different. I am going to leave these leads on here. Okay. So I have 897. I'm going to do something here. See this little bulb here? I'm going to add this in parallel. Maybe. I dropped down to 5.1 ohms. Okay? So I'm going to stand in front over here. You know what this bulb is, first of all? That bulb, same bulb you would have in your test light. So if Brian backs out, and I do this 100 times. Let me get this phone thing, bulgy thing off of me here. Okay? If this was my current, this was my resistance here. Okay? And this was my amps. Okay? Resistance high, amps low. Resistance low, amps high. Remember that computer internally? It's what you're doing. You're going to load it up. You're going to throw all that high resistance in here. And I actually showed you, gave you a reason why you need to use a digital volt ohm meter. As long as I got this board over here, I keep saying, you know, are there differences in meters? I'm going to put this on the bulb over here. I'm still in resistance. And what do you got here, Brian? You know, you can zoom right in real good, you know. 5.3. Okay. Now I'm going to take one of these other meters here. I'm going to shut this off. And for the sake of argument, let me pick this one. The reason I bought these meters here is because I want to kind of like, you know, have spare meters around. So when the guys don't have a meter, I can't afford to buy 10 huge fluke meters. So, but a meter is a meter. This one here, when I turn it on, okay. All right. And if you zoom in over here real close, this, they call it a smart meter. So if you look on the bottom over here, smart, I don't know how close you can see it, it actually tells you put this lead in that pocket, put that lead in that pocket. So what happens here is I'm going to real fast pick a function here. Okay. As I change, I'm in ohms. Now, it's the little thing that wind up being a pain in the ass. This meter, my fluke, they all have a, see that where I can kind of lay it down like this? There is nothing on this meter. And I'm one of those guys, this could be a real pain in the ass for me. If I wanted to lay this down like this, it's like, you got to be kidding me. Where am I, you know, and this perfect proof of, and then the reason I want it facing me someplace is because I actually want to put the leads on there, okay? So what I'm going to attempt to do is put these leads on. I love my alligator clips, so I'll try to do it this way. What did the fluke say, 5 point something? And this one's not bad, 5.0, 5.5 amps, okay? So, pain in the ass with the bottom over here, okay? Hooking it up. Oh, by the way, if I go to amps, I guess maybe that's why they call it a smart, I'm gonna hit to amps, whoops. Damn it. Keep going past it. Okay, I'm in amps. And I don't know how closely you can see this, okay? And all of a sudden, the reason they call it a smart meter, okay, if you hone in, you hone right in, Okay? Okay? And basically, you see this little arrow here? It's telling me to switch pockets over here. Okay? And that's what it's trying to do, you know. So it's a smart meter that tells you, hey, stupid, you went into amps, you switched the pockets. And you heard that little beep, you know, then I'm okay. So, okay. So that's one meter. So let me try one other one here real fast. Turn this one off, get it out of the way. Because again, I prefer my amps. Now this is the one I believe I was messing around. Okay. Now this one's not too bad. I put it on ohms. Okay. And this does have, you know, for the price. I can't remember what I paid. I think it was only like $60, $50 or whatever. Not bad. Touch my leads. Okay. And I have, see how it's floating around? I'm not happy about that one. Okay. It seems to float a lot. And I know my battery is okay, you know. So I do have some resistance. They're not the best of everything. But if I put them over here and watch how they kind of like bounce around a little. Okay. See the numbers bounce. Okay. And it's going from 23 down to 15. So this meter, I'm not, you know, granted, I can put it down nicely, but I've always found a little bit of issue. Even when I let the other guys use it, it's not totally accurate, you know, where the fluke stays steady, you know. So again, I guess what I'm trying to say is that sometimes maybe you get what you pay for, you know, but my point being too is that regardless if that's what you can afford, you know, Jay, don't let the smoke out. Absolutely. You know, can't put it any better. You know, it doesn't even have to be a computer circuit, you know. The secret, you know. Yep, I would have to chunk that one. Yep, but again, like I said, you know, doing electrical classes, you know, I'll be very honest with you. I got a couple that I think I showed last month that I've gotten from that, but, you know, the 40, 50, they, they work pretty good, you know. So, no, I haven't, I can't remember if I did play around with the test leads. That's one of the things I always do also. So, again, easy to read. We left off, you know, don't forget, whatever you do, you get in computer work, use that Meg Ohm. Okay? And that's what I just did. So I jumped ahead a little. Most of the time, I'll be very honest with you, the most common kind of that I find that everybody uses their meter for is that open circuit voltage test. It's probably the most commonly used test. Open circuit voltage allows a battery state of charge to be determined using a digital volt ohm meter. And I've done starter and battery stuff, and you know, you can always go backwards on I think atts.com, and you'll see, you know, where I've highlighted a little more on that stuff. But, you know, if you want accurate, just a little reminder, remove your surface charge first to obtain an accurate test result, you know. Good reading would be 12.6, you know. And, you know, you want to kind of look at it as a steady state or no low battery voltage reading used to determine the state of charge, you know. And, you know, and I'm always surprised you get down to like 12.5 or thereabouts, how rapidly the state of charge in relationship, when you look at the charge, has dropped, you know, down to 75%, you know. And most of the time, you know, you put them on most batteries, chances are pretty good, you know. It's what you're going to wind up with, 12.54 till you give it a quick charge, you know. Now, voltage drop is a huge thing, okay? Voltage drop, you know, but I'm also using this connection. You can actually call it a voltage drop, okay? And the reason we call it a voltage drop, this is a parallel connection. Meter is placed across the load, and the number of volts measured will be available voltage or voltage consumed. And the key to it is you look at also as voltage consumed by a load. And that's a good way of starting a voltage drop, but, you know, but again, if it's a load over there, you know, as far as those electrons go, you know, every single electron that left that source is going to go right back to the battery. So, and that's where an amp meter comes useful, and you can check that out. And speaking of measuring current, biggest takeaway from this, you already know, make sure your fuse is working. Okay. So many guys, someday they'll figure, like, you know what? I want to take a dynamic amp reading. I want to see what's going on. How much is the solenoid drawing? Is it drawing too much? Is that the cause of my computer getting fried? And so on and so on. So somebody might have told you, hey, you need to take an amp reading. And that's a perfect example. You can cause some issues. Whatever you do, you need to break into that circuit. If you don't, you always use those inductive clamps, but you get a much more accurate reading. You have to break into that. Meter becomes part of the circuit, okay? Basically, it becomes an electron counter. The other important is know the anticipated amp reading. There are limits. You go beyond that, okay, and zap, there goes the fuse, and you have a couple of pockets. Again, typically you got your 10 amp over there. I believe years ago I had an OTC, I believe that had 20 amp, and I still see a few amps with that high of a reading. But your other pocket in there, you have a lower amp pocket, usually within an amp or thereabouts. Before you go putting in that pocket, you need to make sure that that you're going to work with milliamps and stuff like that. So that's important. Okay. Again, I mentioned some fuses can be pricey. Resistance, of course, disconnected. The power source in your meter, okay, will supply that component or that circuit so you can take a reading. The meter supplies component with a known amount of current. Meter will calculate the resistance of the component. So make sure you have a good internal battery, and like I said, that 1 meter over there floating all over the place, so, again, this is where a good, steady, rock hard meter, and I see a lot of guys coming in with, not so pricey meters in the class. And a lot of them, one of the first things say, oh man, I see the guy over there is got a, OTC or Fluke or something. He says, man, they're rock steady hard. Mine keeps on floating around a little bit. Well, we're back to the same thing. Usually I tell them, check the battery. So my friend Chino, he's on over here today too. I said hello to him. He likes to share a few things with me, and Gino years and years ago came through all my classes, my engine performance and fuel injection. That's how far back we go, and he lives and breathes this stuff. So sometimes he'll throw me a little stuff that I've forgotten, and this is good, So this one is a real good one here, and I figured I'm going to throw it in, and you guys can try it. This is an exception to using the ohm meter on a dead circuit, because again, I just got through with a slide, dead circuit, dead circuit. However, you can use the ohm meter on a battery negative cable. Obviously, it's live, but you can make an early determination if there's an excessive parasitic current draw. Basically, and this is in your handouts, step 1, you zero out the ohm meter. Step 2, hook up the red lead to a body or chassis ground and the black lead to a battery negative terminal. You want to observe the readings. Typical value would be around 20 ohms. And of course, think of all the modules we have on these vehicles. As each module goes to sleep, that ohm reading will drop. So roughly after 20 minutes, and I think when I did CAN and multiplexing and stuff, we in trucks, believe it or not, we have modules that are going to stay on for hours. So you kind of have to know, what's going to stay alive, what goes out. But anyway, so roughly after 20 minutes or so, you should see the ohm reading to 0. Anything above 0 means that you are justified in taking your next step, taking out your parasitic test equipment and methods. Mm-hmm. So pictorially, again, you can do all this stuff. Testing for available voltage. Remember, you hook it up in parallel. you know, the ground side, you got the feet side, you know, and basically, you know, even up there on top where you have the butt connector. Yeah, you have the butt connector. That's a good source of, you know, that's a very good source of issues here. Unwanted resistance, you know. But basically, if you look at it, you know, on a battery, of course, you're going to have 12 volts and so on and so on, you know. So you always check the ground side for voltage drops too. So that's one way of doing it, you know. Another meter that you might get into, you know, taking insulation resistance. I know that most of you guys, unless you work for some bus companies or whatever, you might not get into high voltage systems, you know, insulation resistance and all that stuff and everything else. But if you get on those electrical vehicles, and don't get me wrong, you know, a lot of times, you know, the circuitry inside those systems, you know, if there's any kind of a resistance leakage, the chances are pretty good they'll catch it, and you know, you're not going to go anywhere. But still, you're the guy's going to have to figure out which cable, where is my leakage over here, okay? So the purpose of this Meg Ohm meter, you know, is to check for voltage leaks in the cable insulation ground, you know. To initiate an reinstallation test, rotary switch is turned to the desired test voltage. And you got a lot of choices in here. You know, I'll hold it up and, you know, to see it a little bit better in a minute. Okay. So this will cause a meter output a high voltage and measure the insulation resistance. You know, you're basically going, you're starting with low voltage, go higher voltage, you go higher voltage. It's just like think of a water hose. Maybe if you think that water hose has a leak someplace, you know, or maybe a air system, you got a leak. Start building up the pressure, and all of a sudden, whoo, there's my leak, okay? And that's what you're trying to do. You know, the leaks are possible in electric high voltage cables due to accidents and maybe even rodents, okay? So keep that in mind. Of course, we've all seen the rodents. This is a Meg Ohm meter here. This one is nice too, okay? So basically what happens is, here is my test voltages, okay? So you can even zoom in if you want. Got the 120, 25, 250, 500, and of course I'm going into 1,000 volts. So again, you hook it up, hit the test button, okay? And this does have a continuous lock. It does have a mini max on it. And of course, it does give you the feature here. If you're not playing around with this portion, okay, it's still a meter. You paid for it. It still gives you an opportunity to look at volts AC, okay, volts DC, okay, and of course, ohms. So it's not that you're investing into a Meg Ohm meter and then all of a sudden it's going to sit there forever and ever. Hell, you got the options to use it for so many different things. So that's a Meg Ohm meter. Okay. So let me see where we're at with our slides here. Not just a Meg Ohm meter, but anything that you're working with high voltage, the Cat type, you know, Cat 3, Cat 4 shields, they're used to reduce what we call arc flash. You're going to notice many meters have them, regardless. These shields may be removed for Cat 2, taking measurements to reach, if you got to reach recessed conductors, you know. So if you're going to ask what is a Cat 3, this is a description right from International Electrotechnical Commission. Cat 3 equipment is designed to protect against transients in equipment and the fixed equipment installations such as distribution panels, feeders, short branch circuits, lighting systems, and large buildings, and so on. So again, a lot of this stuff, we're not the only ones. We started to get into this high voltages when we started to get into hybrids and so on. And this is a perfect sample. Insulation test from HV wire, shield to body ground. This is a good reading, okay? So, who is the head of the Dorman Training. Okay, he's got a real kick-ass, hybrid and plug-in electrical vehicle class that periodically holds, and he's got a online webinars that he does on that and travels all over. Actually, to tell you, years and years and years ago, I kind of had to navigate away from there because trucks, again, don't have that many, but G and I and a couple other guys, we actually, put together a nice little hybrid class. So, but you ought to go online, look at all that stuff that's on there on Dorman Training Center. So I'm going to hit this back. Now, another thing that this meter has here, and I'm going to play around a little. The rest of the time is we're going to see what kind of trouble we can get into. Okay? So if you can hone in over here, I'm going to take this stupid simple switch over here. I'm on my ohms, but I also have, I got the switch off, and I have an alert button, And the reason I have the alert button, if you can probably hear when I turn on the switch, you hear that little beeping? Okay? Annoying little beep. What that is, that makes it kind of convenient that when you're sitting inside the cab or something and you're trying to make a connection and everything, and finally you make a connection, meter is someplace else, and it's like you make the connection, it's like, oh, I hear it. I think I'm in the right area, if that makes sense. Okay? Now, we're gonna hopefully see what we can do with this. I'm gonna hopefully place this meter in an area where we can see a lot of this stuff here. And this, I'm gonna definitely try to do by the seat of my pants here. I'm gonna turn this on, okay? And we're just gonna mess around with this. You able to see this pretty good? If you hold, yeah, zoom right in. That's not too bad, because if I put a reading on, you might see it a little bit better. So let me put a reading on. 0.03, not too bad. I should have had a better, let me turn that light on over there. It won't take me but a second. Maybe that might help a little bit. Such a hurry, I forgot to do that. You'd think we'd have any better or no? Not really. Trying to find a good spot for this and still keep my cables halfway decent. How about if I pull this a little bit closer without destroying anything, Yeah, I don't have a driver's license here. See if that's any better. Let me get my other fluke on. I can switch leads because I like the alligator clips.
What? I mean, you can see it.
Yeah. Better?
Have to, yeah.
Okay, I'll switch leads. Won't take me a second. The reason I'm going to switch my leads are, I do like the alligator clips, I'll be very honest with you, because it leaves both hands free. Everybody's a little bit differently. So I'm going to put comment, I'm going to do that, okay? And I'm going to flip this up. The only problem is I can't flip too good, but I got this little hook over here that I'm going to put this on. And if I put this on volts, any better? It's going to have to do. So one of the things we're talking about doing a voltage drop, okay? So I have a horn hooked up over here. I'm going to put a positive, negative, 12-volt horn, right? I'm not going to do anything, no voltage drop or anything's going to happen until you have to do what? You have to turn the circuit on, right? So if I turn the circuit on, dropped a little. It used up 12.2 of, and I had whatever over here. Now, if I wanted to do a voltage drop that I'm looking for unwanted resistance, I'm pretty lucky the way I have this hooked up. I like to start on the negative side because everybody talks about the positive side, positive side, positive side, but just think about a typical vehicle. You're going through the chassis, you could have straps and everything else. So I'm going to go from my negative, and that's my negative battery post, you know. And I can go right to the battery to eliminate this section here too, but I'll have to bend down. So what I'm going to do is right now, I put it on. I have nothing. Uh-oh.
Black show.
Oh, yeah. Just so you guys know, right here, okay, this is case ground on the back side, okay, this solenoid needs a case ground. I have it on the bolt in the back. I forgot I took it off earlier, okay, and all day long. But to tell you the truth, that's a perfect example. It wasn't working, was it? What if this was a solenoid, you needed a case ground, and you didn't have it? What if you didn't even realize that this is supposed to have a case ground? So now we're back to where we were, okay? So I'm going to 0.002. Okay. I truly have a good connection over here. So if I'm going through a chassis or something, that's what I'm looking for. Am I dropping excessive kind of a unwanted resistance causing a huge voltage drop? And again, on a truck, especially, think about the environment we live in. You know, and to be honest with you, even with small trucks, look how many times you found those straps on, what is it, GMs, the no starts and stuff? The straps, the ground straps and stuff, they break. Yep, absolutely won't even start, you know. Now, we can do the same thing on the positive side, okay? So I'm going to go to positive side. And again, I should really go to the battery, you know. But what I'm going to do is I'm going to go to, again, I'm trying to figure out, you know, my starter, everything. You see the huge red cable, so everything really winds up coming from there. So I'll do the same. On the positive side, I had a 0.3 whatever. That's not bad, guys. But that's what you're trying to do. So if you have unwanted resistance, you're going to have to try to figure it out. You're going to have to hone in. Is it from here to here? You know, hone in. Is it from there to there? Now you got to do your individual, you know, cables, see where you're, you know, and most of the time, to be honest with you, you guys know it's going to be what? Connections, you know. So actually this particular board here, when we first built it for a competition, trucking, we call the SuperTech competition years ago, we took a battery cable and I was able to find some plastic inserts, and we would actually put it between the cable and that, and it was so hard that you couldn't even see it. But guys would go to try to start, nothing happens, and then all of a sudden they're over chasing down fuses and everything else, and basically wound up. It's like if you didn't go to the battery and find it, you know. So
if you had a bad resistance or connection, you would see voltage on the meter then?
yes, yeah, you drop your actually, and this is not what you want. And in this particular case, I'm really great with the voltage, and I start seeing some huge voltage drop. because the whole it was a good question, because technically any kind of a load, like for example this thing here, if this was supposed to be 12 volts, and if this is the only thing on there, this should use up source voltage 12 volts. So if for example this is only, you go over here to 11 volts, I'm just using round numbers, or 10 volts, where my other 2 volts go to? Somebody stole them. So you're basically trying to find a thief who stole those voltages, But again, you can do these things all day long, okay? Amperage, big thing with amperage, and I did that last month, remember? And I didn't switch these leads because I spent like good 5 minutes telling it over and over, make sure your pockets are switched, make sure your pockets are switched. So I went to do the amp reading over here, and I kind of did it like this so nobody could see. And all of a sudden it's like, man, it's not working. So I was waiting for anybody to come out and say, hey, you didn't switch the leads. So finally I switched the leads, and I kind of told everybody, says, come on guys, how observant were you, So we're going to do that in a minute too. But speaking of voltage drops, here's a perfect thing. We'll get the blower motor going over here. So no big deal. We know, it's 12 volts, and we have a bunch of speeds here, okay? We have a resistor over here. So we're going to do our meter still in volts over here. Now I'm going to turn on the blower motor, okay? And hopefully my son Brian got this back in shape, because we used it in a competition this year in June. And I mean, you'll see, I'll show you in a second. But anyway, I'll turn the blower speed on. Okay. Here it is. And I can switch the leads. It's got a negative in there on front. Don't worry about it. So I'm using 8.53. I'll go to next speed. I'm up to 9 volts. Go to next speed, 11.60. It goes on. And I do have a little bit of a drop here. I haven't checked it. But as you can see, every time I drop off one of these resistors, I'm going to give this blower motor more and more current, okay? Now, that's nice. So you can basically do that anywhere where you can get access to feed this thing. The other thing I'm going to do is I'm going to take a direct current reading, okay? I'm going to look at the chat box a minute. So if I take a direct current reading, anybody that's on there, what do I got to do? I'm looking at chat real fast. Don't talk at the same time. Anybody? Guys can't type faster than that? What do I got to do if I got to take an amp reading? Oh my gosh, all of a sudden everybody's coming in. Move test leads. Check the leads. Put in series, blah, blah. Awesome. Okay. Thank you, guys. This time, you said change the leads. I'm going to do an amp reading, right? It has to change. I got to go into amps. The next thing is I have to what? With this particular case, break into the circuit, which I am going to do. Now this meter becomes part of the circuit, okay, all day long. Okay? So now when I turn this to amps, down here, direct amps, I'm going to do the same thing. I'm going to turn this on. 3.4. Fluctuates a little, 3.9. 5. Settles down to 4.5. Okay, so you saw it rise each time that the speed changed. Okay, more current came into play. So the relationship between voltage and amperage is huge. Okay, so dynamically looking at amps is absolutely great. Okay, when I do my ABS classes, I power up the ABS solenoid, and I actually put an amp probe around it. The reason I put the amp probe around the solenoid, I use my power probe, and I try to prove a point. Typically, the best place to do it is right at the computer because you got so many harnesses and connectors along the way. So if you baseline and you're comfortable, if you turn on your ABS solenoid, say 2 amps every time where they've got an inlet, the supply or the exhaust solenoid, and all of a sudden you turn it on and you use your amp meter and it's got like 3 amps. Well, this is not what I usually use, okay? Usually you use 2 amps. So we're back to the same thing. If I got an electrical resistance, okay, let me back this up. If I come up with 2 amps, and I'm baseline, resistance electrical is high, okay, and that brought my current down. So I could take a chance that solenoid might not work properly. I jumped a step ahead, but if I'm comfortable with 2 amps and all of a sudden that amps is way up, I'm drawing like 3-4 amps. What do you think is happening inside that solenoid, right? You got too much of a internal mechanical resistance. You're trying to build up and open up the solenoid. It's sticking, whatever the case may be. So amp readings are huge. Again, keep in mind, this is why we're doing this meter stuff, okay? You need to get comfortable with using these meters. Okay? I'm going to do, this one here is, actually, let me, I have this other thing. We talk about amp readings. I'm going to make sure I'm going to switch pockets. And speaking of power probes, wherever I put it, this particular power probe over here, okay, if you look over here, I have an amp kind of a reader in here. Okay? So basically what I can do, I can put this in series, right? I need ground, I need power, am I right? Okay? So if I power this thing on, I hook it to my battery, okay? And what I'm going to do this time, this is an adapter that you put on, okay? And it's fairly safe. Okay? I'm going to turn it on, and I might have to tell you what's happening. So I'm a milliamps right now. So what I'm going to do is I'm going to take this over here. Again, I got to break into the circuit. Okay? And what I'm going to do over here, oops, wrong wire, stupid. Trying to rush again. Mm-hmm. So I'm going to break into the circuit. Everything's in the way here. I'm going to hook this to here. Okay? And when I turn this on, 4.75, 4.5 amps. I don't know if you can read it. Okay? And actually, at the same time I'm powering this on, I'm also taking an amp reading on this thing. It's a great way of really doing it safely. You know the purpose of the power probe to begin with, So the other thing, I mentioned, that eventually you might have to get into doing a parasitic draw. And I just ran, and I think Chi did that on a car. He highlighted this on one of the lunch and learn. So I'm going to show you something real fast. If you see this thing over here, okay, so basically it's a draw monitor. Now, what you're going to wind up doing is you put this thing, you're going to use the internal battery inside this thing here. On a car, for example, you plug this in over here. Okay? So once you have it plugged in, you're going to put it in a smart output. It's going to get turned on. And basically what you're going to do is you're going to disconnect the battery, the car's battery, and then you're going to watch this. And it's enough to let the controller stay, make sure your doors are closed and all that stuff. But you can watch as each one of the controllers goes down, goes down, goes down. And if one stays on, This will stay on. You can time it, and it will let you know if something is on. So I started to think about, well, we're into trucks. So what I did was we used the Chaser 1939. So I said, I wonder if I can come up with an adapter. I came up with this adapter, and to play it safe, I needed to know, which pins are for the ground and power. So what I did was I found this, of course, that I got all day long in my multiplex and OBD. I compared it, checked it off for my 16 pin, matched them up, and voila. Plug it in, I can do the same thing with a truck. Okay? I think we're gonna call it. Most of the time, it's like you guys, you're shorthanded. The one thing I didn't get to, and I'll probably save it for some other time. I got a Neuron N2. Okay? It's another meter. It basically works with this tablet here. It syncs with this, it's Bluetooth, and I did have it hooked up to my throttle position sensor here. Okay. And power it up. I have it hooked up, and the nice thing about that, it actually will show the voltage as I'm going this, prove a point that I don't need to have a throttle position sensor on a vehicle. I can do it, just all I need to do is feed it 5 volts, okay, and this power pack will do it. Actually, I got a bunch of 5 volt stuff here. This one's from Bosch. I can insert 5 volts with this. Here's a homemade one. Okay. Radio Shack days, it actually works. 5 volts. Reason the LED is, and if I put a meter on, that'd be exactly 5 volts. But you know why that LED is on? Because I'm getting old and senile. Sometimes I might forget that, I turn it off. There's a 9-volt battery in there, and I put a voltage regulator in there. And by the way, actually, Power Probe, it's got one of these also. I got a couple of these. You can feed 5 volts for reference. So there's a lot of stuff out there. A lot of them aren't pricey. The other thing I have over here, I think I tried to do it last week. This is a fuse monitor by Power Probe. Okay. And basically, I try to, I'm going to have to do it at some other day, some other month when I get do some more stuff. But basically, you turn this on. Okay, and then you go into your function over here in your mode. Excuse me. Battery dead already.
Should have had a flashing LED.
Should have had a flashing LED. You're right. Oh, there it is. But it's too hard to see, but it came on. So basically, you just put on there what type of fuse you have, and you go up and down, put the fuse rating. And this one here, you just basically, you put it on a fuse, and this actually has an alert, I don't know if you can see it, it'll say it's open, it's active, okay, or inactive. And then whatever you're doing on the fuse, you turn it on, it's so nice, you sit there like this, and you look at it, turn it on, and you get the activity of, how much amps is coming through that particular fuse. Just think about this, guys. Is that important? Damn straight. You got some circuits where you're blowing the fuse over there, and the fix is not putting a bigger fuse on. You got to kind of once in a while know, what is my limit? This is a nice way at least to try to find that nice sweetheart's range. It works great if I'm over here like this, but the only circuit, these are false fuses in there. We were messing with, guys, false wires and stuff. Over here, I have a hard time, and that's the only reason I didn't do it. This is for the blower here. You kind of need it, that's my one drawback. Making that connection is a little bit hard. So anyway, I'm going to leave it at that. Okay? I'm hoping, Eddie, yes, I have one. I love the N2. Yeah, the N2 is great. I mean, you can really see it real good. You can see, you can graph with it. And that's one of the reasons I wanted to show it, that a lot of meters that bar graph when you're doing anything that's sweeping, it's okay. The premise is, It's supposed to substitute for the old analog where you get the sweeps with the analog meter, but to see a dropout is a little bad with that. But the N2 does a real nice job, and I got a current probe for it and so on. So we're done with this thing over here. Okay. If there's any questions, shoot them out. Okay. Got a few minutes here. And if you can, please, again, I keep telling everybody, try to, if you can, you don't have to, I mean, if you think these lunch and learns suck, of course, say it, but if you do, you can go on webinar on their webinar survey, for example. I don't know what face group they have over there, newsletters, but, throw a little thing. And also with you heavy duty guys, I try to tell everybody, it's like, there's not too many guys out there doing heavy duty. So if you guys are looking for anything specific, shoot it out there, or get a hold of me, or get a hold of Dorman. Hey, I'd like to see something on this, and whatever the case may be. So thank you, everybody. And Doreen, you still on?
I am. Thanks so much.
Yeah, this went fairly, compared to last night where we had those hiccups. This went very, very, very nice.
Perfect.
Yep. And again, everybody that came on today, I really, truly appreciate you supporting this, because it's kind of indirectly supporting me, meaning that, it keeps me going, as far as motivation. So thank you, guys.